Hello everyone, this is GV Srinivasrao. Welcome to my channel. The present topic Chemical Kinetics Module 2. In this module, let us discuss about the factors affecting the rate of the reaction. Please subscribe, comment and share.
Factors affecting rate of the reaction. Number one, concentration of reactants. Concentrations of reactants. Pressure in case of gaseous reactants. Gaseous reactants are products. Then temperature and catalyst. Now let us discuss the factors affecting the rate of the reaction, concentration of the reactants, pressure in case of gaseous reactants and or products. The third one is temperature and the fourth one is catalyst. Now let us discuss about each of these factor thoroughly. Effect of concentration on rate of reaction. Rate of reaction increases as concentration of reactants increases. The representation of rate law. The representation of rate law of a reaction in terms of concentration of reactants is known as rate law. The representation of rate of a reaction in terms of concentrations of reactants is known as rate law. So, representation of rate in terms of concentrations of reactants is rate law. Now if we take a hypothetical reaction is AA plus BB gives CC plus DD. Here capital A, B, C, D, A and B are reactants, C and D are products. Now the small letters A, B and C, D, they are the stoichiometric coefficients in the balanced chemical equation. Now let us write rate can be expressed as rate is proportional to concentration of A to the power and concentration of B to the power raised to Y. Here concentrations are represented by keeping the symbol of the element or formula of the compound in square brackets. Now rate is proportional to concentration of A raised to the power X, concentration of B raised to the power Y. So rate is proportional to A to the power X into B to the power Y. Or rate is equal to remove this proportionality, we have a constant K into A to the power X into B to the power Y. Then what is rate? Rate is nothing but change in concentration by change in time. Change in concentration by change in time. Right. So this is nothing but change is represented by D into R. R is the concentration of reactant. We studied that the concentrations of reactants go on decreasing when the reaction is proceeding. Therefore, the decrease in concentration is denoted by the minus sign, by change in time is dt. Therefore, minus dr by dt is equal to k into a to the power x into b to the power y. Therefore, this is referred as rate equation, and k is the proportionality constant known as rate constant. Now let us define the rate law. Rate law, rate law is the expression in which rate is given in terms of molar concentrations with each term raised to some power, which may or may not be same as the stoichiometric coefficients of reacting species in a balanced chemical equation. Now let us see an example. 2NO gas plus O2 gas. Nitric oxide combines with oxygen to form nitrogen dioxide. So nitric oxide combines with oxygen to form nitrogen dioxide. Just by seeing the balanced chemical equation, we can write the rate is equal to K into concentration of nitric acid raised to the power stoichiometric coefficient 2 into oxygen O2. Here the stoichiometric coefficient is only 1, therefore it is 1. Now, whether this exponential terms, that is 2 and 1, may be same or may not be the same, we can find only by doing the experiment exactly. So this is the rate law for this reaction. So in this way, just by seeing the reaction, we can write the rate law, but these exponential terms can be known only when the reaction is conducted exactly. Now let us see the reaction between chloroform and chlorine. Chloroform reacts with chlorine to form carbon tetrachloride and hydrochloric acid. Now rate can be written as rate equal to K into concentration of chloroform raised to the power 1 and Cl2 raised to the power 1 by 2. Similarly, CH3, CH3COOC2H5. What is this? Ethyl. This is ethyl acetate plus H2O. This is hydrolysis of ester. We get CH3COOH plus C2H5 OH. Now rate equal to K into concentration of ethyl acetate CH3COO C2H5. Here the concentration of water is not affecting the rate of the reaction. So from these examples, what we understood, rate cannot be determined just by taking the stoichiometric coefficients. So rate law cannot be merely expressed by raising the concentration powers equal to the stoichiometric coefficients, and these powers should be found by doing the reaction experimentally. Therefore, rate law just cannot be determined just by saying the reaction. Suppose a reaction A plus BB gives CC plus DD. Therefore, rate equal to K into A to the power X, B to the power Y. Sometimes these exponential terms X and Y may be equal to A and B or may not be equal to A and B, that is stoichiometric coefficients. Therefore, we have to do the experiment in real to find the rate law. Now rate law can be found by using initial rate method. Initial rate method means if we have a hypothetical reaction AA plus BB gives C plus D. Now in this reaction, in this experiment, let us take the fixed concentrations of A and B. Now in the next step, keeping the concentration of A fixed and raising the concentration of B, the concentration may be raised to either double or triple, then rate can be found. So in that step, we can find the exponential term of concentration of B. Similarly, in the next step, keeping the concentration of B constant and changing the concentration of A, then we can find the exponential term of concentration of A. Thus, we can find the rate of the reaction, and of course, this method is referred as initial rate method. Rate law can be found by initial rate method. Concentration of different reactants are found at different time intervals, and exponents can be found. Now let us try to understand this concept by taking an example.
Rate of the reaction can be found by initial rate method. Concentrations of different reactants are found at different time intervals and exponents can be found. Let us understand the concept by doing an example. The following results have been obtained during the kinetic studies of the reaction 2A plus B gives C plus D. The tabular form for experiment, molar concentration of reactant A, molar concentration of reactant B, and initial rate of formation of D in moles per liter per minute. Now in first experiment, the molar concentrations of are 0.1 and the rate is 6.0 into 10 to the power minus 3 mole per liter per minute. In second experiment, 0.3, 0.2, 7.2 into 10 to the power minus 2, and in third experiment, molar concentrations of A in first and third experiments are same, whereas that of B is 2.88 into 10 to the power minus 1, and in fourth experiment, the molar concentration of A is 0.4 mole and that of B is 0.1, and initial formation of D is 2.4 into 10 to the power minus 2 mole per liter per minute. Determine the rate law and rate constant of the reaction. This is the problem, and let us find the solution, and of course let us find the rate law and rate constant.
Rate equal to K into A to the power X into B to the power Y. Now from experiment number 1, R1 equal to K into 0.1 to the power X into 0.1 to the power Y. That is in first experiment. Concentration of A is 0.1, concentration of B is 0.1 is equal to 6.0 into 10 to the power minus 3 mole per liter per minute minus 1. Now R4 equal to K into 0.4 to the power X into 0.1 to the power Y, that is concentration of A and concentration of B, is equal to 2.4 into 10 to the power minus 2 mole per liter per minute. Now R4 by R1 equal to K into 0.4 to the power X into 0.1 to the power Y by K into 0.1 to the power X by 0.1 to the power Y is equal to 2.4 into 10 to the power minus 2 by 6.0 into 10 to the power minus 3. This is nothing but 2.4 by 6 into 10 to the power 1. Now here bases are same, so can be cancelled, x and x cancelled. This is 0.4 by 0.1 is nothing but 4 to the power x is equal to, this is 24 by 6 equal to 4. Implies 4 to the power x is equal to 4 to the power 1. Therefore x equal to 1. Thus order of the reaction with respect to x is, with respect to A is 1. Similarly, from experiments 2 and 3, 2 and 3, R3 by R2 equal to, that is reaction 3 by reaction 2 equal to K into concentration of A in reaction 3 is 0.3 to the power X into 0.4 to the power Y by K into 0.3 to the power X into, this is 0.2 to the power Y is equal to, then what are the experiments? This is 2.88 into 10 to the power minus 1 by 7.2 into 10 to the power minus 2. So here x terms cancelled, k get cancelled, therefore 0.2, 0.4 by 0.2 is nothing but 2 to the power y equal to 2.88 by 7.2 into 10 to the power 1. This is nothing but 28.8 by 7.2. This is nothing but 4. So here 2 to the power y equal to 2 square implies y equal to 2. Therefore, order of the reaction with respect to B is 2. Now rate law equal to K into A to the power x value is 1, B to the power y value is 2. Now this is the rate law. Using any experiment we have to find the K value. Now rate 1 equal to K into A to the power x into B to the power y. What is the rate value? 6.0 into 10 to the power minus 3. Now implies K into A, concentration of A 1 into concentration of B is also 1 to the power 2 is equal to 6.0 into 10 to the power minus 3. This is nothing but 0.1 into 0.1 to the power 1 into 3. Therefore, this is K into 0.1 to the power 3 is equal to 6.0 into 10 to the power minus 3. This is nothing but K into 0.001 is equal to 6.0 into 10 to the power minus 3. This is nothing but K into 10 to the power minus 3 is equal to 6.0 into 10 to the power minus 3. 0.001 can be written as 10 to the power minus 3. 10 to the power minus 3 get cancelled, implies K equal to 6.0. Now what is rate law? Now rate equal to K into A to the power x into B to the power y. Now let us apply equal to 6 into A to the power 1 into B square. So this is the rate law. Now let us learn about order of the reaction. Order of the reaction. So order of the reaction is nothing but the sum of the concentration terms of reactants in the rate law. For example, if we take reaction 2NO plus O2 gives 2NO2, that's all. Now rate law, rate equal to K into NO to the power 2 into O2 to the power 1. Now order of the reaction is equal to 2 plus 1. Therefore order of the reaction is 3. Now for a hypothetical reaction, AA plus BB gives CC plus DD. Now rate equal to K into A to the power x into B to the power y. Exponential terms x and y found exactly by doing the experiment. Now order equal to order of the reaction. Order of the reaction is x plus y. Sum of the exponential terms in the rate law. Now, let us find the units of rate constant. Units of rate constant. Now, rate equal to k into a to the power x into b to the power y. Now k equal to, bring this to the side, rate by a to the power x into b to the power y. This is nothing but, how do we find the rate? Rate is nothing but mole per liter per second. Mole per liter per second by a to the power x into b to the power y. Now this rate constant for different order of reactions differs. Now let us discuss the values of rate constant for different orders of the reaction.
We conclude this module here. Thank you.